Hi everyone! I'm really excited because today I'm going to show you guys how to use sine, cosine, and tangent in a completely different way. We're going to solve for sides and angles in a triangle without using SOH or TOA. And to do that, we're going to start by defining our triangle, our sine, and our cosine in a completely different way. So we'll start with the triangle. We'll start with, let's call it theta down here, right? Sort of your standard Greek letter for an angle. And this thing here is called a unit triangle. So a unit triangle is a triangle, it's a 90-degree triangle with hypotenuse equal 1. Okay, now a unit is just the fancy math word for 1. Now here's what we're going to do. We are going to define, so by definition, this side here is sine of theta. And by definition, this side here is going to be the cosine of theta. Now you'll notice this is a completely different definition. You don't need to define sine and cosine in terms of two sides divided by each other. You can just define sine as this vertical side here. You can sort of think of sine as the y, the vertical, or the height of the triangle. And you can define cosine as the x, or the horizontal, or the width of the triangle. And this gives us a really powerful understanding. So cosine you can think of as the x component, or the width, the horizontalness of a triangle, and sine is the verticalness, the y of a triangle in standard position. And by standard position, I mean we're always going to have theta down here in the bottom corner with our right angle right here. Okay, so like this would be standard position if you've got your angle, let's say this is 22 degrees down here, that's standard. Or if you've got a triangle like this, and let's say up here is 55 degrees, that is not in standard position. What you would need to do to get this into a standard triangle, you need to change that to a 35 degrees down here, right? Because 180 minus 90 minus 55 is 35 degrees. Okay, so you're in standard position, you're always going to have your angle in this bottom corner. And then if you're in standard position, then this side here is your sine of your angle, in this case 35 degrees. And this side down here is the cosine of your angle, your 35 degrees. And what makes this really cool is you can then start thinking in terms of rotations. You can think about having, I don't know, let's say you've got someone swinging a baseball bat, because I'm really sad that baseball season's canceled right now. So here we go, there's our baseball bat. So you can imagine someone taking a baseball bat and swinging it in an arc. Okay, and I want to know how vertical is this baseball bat at various points along this curve. So if we're at sort of this point along the curve, you can imagine turning that into a triangle. And then you can talk about the sine of whatever angle down here the bat currently is from horizontal. So that is the sine of theta, is the vertical piece, and down here is the cos of theta, which is the horizontal piece. So just to like give you a sense of some of these things, let's just throw some angles up here. Let's do 15 degrees, 30 degrees, 45 degrees, 60 degrees, and 75 degrees. And let's talk about this is sort of a bit weird. We sort of talk about sine first. We're used to talking about horizontal first, but usually we talk about sine first. So let's talk about sine of, let's call these thetas, I guess. So this is sine of theta, and we'll make this our cos of theta. So what are all these different values? Okay, so sine of 15 degrees is 0.259. Sine of 30 degrees is 0.5. Sine of 45 degrees is 0.707. Sine of 60 degrees is 0.866. And sine of 75 degrees is 0.966. Okay, and the first thing we're going to notice is that it's going to be completely symmetrical. So I'm going to fill out cosine down here, I don't even need to look at my notes right now because I know that this is going to be this same value here is the same value up here. Because if you have the baseball bat down here, sort of at 15 degrees, that's like the exact opposite of the baseball bat being up here at 75 degrees. You're sort of switching the baseball bat from one side to the other. This baseball bat, we said the sine is 0.259, which means that this piece right here is 0.259. And the cosine, remember the cosine is the x, the cosine of 15 degrees is 0.966, which means that the sine, the vertical piece of the 75 degrees, is also 0.966. So if your baseball bat's 15 degrees above the horizontal, that means that it's like the x component is about 97% the width of the whole bat. And the vertical component is about 26% of the whole bat. How cool is that? We made an awesome triangle. Like, we can understand the vertical and the horizontal components completely separately. All right, I just got so excited I forgot to fill in my table. Oh, I love this stuff. So this number here, this 0.866, the 60 degree for your vertical piece is going to be the same as the 30 degrees for your horizontal piece. 0.866. 0.707 is going to be the same. It's the exact same because your 45 degree triangle is a 45 degree triangle on the other side. It's isosceles. Isosceles means that your sine equals your cos. They're the same thing because it's an isosceles triangle. Your vertical piece and your horizontal piece are the same. I'm having like a geekgasm over here. This is amazing. Okay, we haven't talked about tangent yet. Okay, so let's talk about tangent. First of all, a little bit of background for those of you who haven't learned this yet. In general, when you're talking about a line, you often care about something called the slope of the line. And the slope of a line is defined as the rise over the run. Okay, so that's like measuring how steep your line is. And so if your rise is the same as your run, if they're the exact same, then that's like a 45 degree angle. And you're going to have a rise, your slope. Okay, this is sort of another weird thing. M is your slope. I don't know why we use the letter M, but we do. But your slope is your rise divided by your run. So it tells you how steep something is. Well, you actually just define tangent as your slope of the unit triangle. How cool is that? You don't need TOA. You don't need like opposite over adjacent. The tangent is the slope of the unit triangle, which means that tangent of theta is the vertical piece divided by the horizontal piece. So let's go back up. Let's remind ourselves. What's the vertical piece of a triangle? By definition, the vertical piece of a triangle is your sine. By definition, the horizontal piece of a triangle is your cosine. So this means that by definition, your slope of your triangle is your tangent of your triangle, and that is your sine divided by your cos. Like, I don't know how you can get more simple than this. I love this stuff. This is so cool. All right, so let's actually go through this and try to solve some stuff with this. Okay. One problem you've probably noticed now is that most triangles don't actually have a hypotenuse of 1. Turns out it's really simple to resolve that, though. If we imagine, what do we need to multiply 1 by to get to h? Well, 1 times h is h. So what we're going to do is we're going to take our sine of, I guess I should label my angle down here, theta. So that's our theta. So this is sine of theta. But just like we multiplied this by h, we multiply this by h. And this side down here is going to be the cosine of our angle theta. And since we've scaled our triangle by h, we scale this by h. So this is just our original triangle, 1 sine theta, sorry, theta's down here, and cos theta. And all that we've done is we've just multiplied everything by h to get h sine theta, h cos theta, and h on our triangle. Okay, let me show you how to solve something for this. So let's set up a triangle. Let's do a triangle that has let's make it a 20 degree angle. And let's make our hypotenuse 10 units. And let's try to solve for this side here, which I'm going to cleverly name x. Okay, that's a clever name, by the way, if you didn't catch this, because that is the adjacent side of the triangle. That's the horizontal piece. The horizontal piece of a triangle is the cosine. The cosine scaled by h. Okay, so what does this mean? This means that cosine of our angle scaled by our hypotenuse is the adjacent side of our triangle. Okay, so this is our adjacent side of our triangle. In a 20-degree triangle, cos of 20 degrees is 0.94. So that means that in a unit triangle with 20 degrees, the horizontal bit is 0.94. Now, this triangle here is just exactly 10 times bigger. So this side here should be exactly 10 times bigger. So this is 10 times the cos of 20 degrees is 0.94. And that's x, which means that x is 9.4 wide. Same triangle if we want to solve for the vertical piece. This vertical piece here, let's call it y. Why do you think I chose that letter? All right, so that means that, like in this triangle, we need the sine of 20 degrees, and the sine of 20 degrees is 0.342. So what's the vertical component here? 10 times the sine of 20 degrees is our vertical component. This is 10 times 0.342, which is which is y. So y is 3.42. Isn't that cool? It's so cool. All right. Next up, let's try solving for the actual hypotenuse. This is a little bit trickier. Okay, so let's say that I know my angle. Oops, that's not a right angle triangle. Let's fix that. There we go. So my angle is 55 degrees, and I know my vertical piece is 7, and I'm trying to actually solve for my hypotenuse in this case. Okay, so let's go back to my definition. The vertical component of my triangle is h, my hypotenuse, times the sine of my angle. So this side here is my hypotenuse times the sine of my angle. So this is an equation I can solve. I just need to divide both sides by sine 55. Divide this side by sine 55. H is 7 divided by sine 55 degrees. And if you work that out, 7 over the sine of 55, which is 0.819, and 7 divided by that is 8.55 approximately. Cool. There you have it. You found the hypotenuse using this idea of scaling your unit triangle by your hypotenuse. Okay, let's try solving for an angle. We haven't done a tangent one either, so let's do one where I give you both sides. So let's say we've got this really tall, skinny triangle. Okay, it's got not much horizontal piece. Its horizontal piece is 14. Its vertical piece is 48. And we're trying to solve for theta. Okay, well, I know the vertical piece. The vertical piece is the rise of my triangle. I know the horizontal piece, that's the run of my triangle. So this is going to be the tangent of theta is my vertical piece over my horizontal piece, because this is the slope. And by definition, tangent is the slope of the triangle. So then all I need to do is theta is tan inverse of 48 over 14, so tan inverse of my slope. And so we work that out, and theta is 73.7 degrees. Okay, last one, and then I'm done the video. Let's try finding an angle using sine or cos. Let's do one that's not very tall. So this side is 15, And my hypotenuse, let's make 39. And I want to try to find this angle here in standard position. This side here, by definition, is our hypotenuse times the sine of our angle, because it's the vertical component, which is the sine of the angle, scaled by the hypotenuse. So this is 39 sine theta. So I'm going to divide both sides by 39. So sine theta is 15 over 39, which means theta is sine inverse 15 over 39. Plug that into your calculator. Sine inverse of 15 over 39 is 22.6 degrees. Oh, I love this so much. So there you have it. If you define in a unit triangle the vertical component to be the sine of your angle in standard position, and the adjacent side to be the cosine of your angle in standard position, you can solve all of trigonometry without any silly SOH memory tricks.